Three, two, one.
Alright, my name is Jackson Lambert. This is my project poem, segment 4, Counting Craters Assignment. And I am here with Jessica Franklin, who is going to be my student today as I teach her how to better understand counting craters. So, Jessica, before we got started, I had you look at these two crater models. The Lunar Highlands, which has a bunch of whole craters all around them. Both have different which has different sizes, elevations. And then I had you look at the Luna Maria, which is the youngest out of these two surfaces and has the least amount of bumps, or I guess you could say craters. Now, I asked you to come up with 3 things that you found. 3 different things you found about the craters. Mm-hmm. So what did you find?
So I found that that there were more craters on one than the other. In general, one was smoother than the other, and the craters, the one with a lot of craters, the craters were deeper than the other model.
Okay. Was there anything visual you noticed?
I noticed that the one with more craters has kind of, in a way, more of a darker color, like inside the craters.
Mm-hmm. Yeah. So, that is very good, because that is actually on the side of the moon where it is darker. You can't see it with your naked eye. So you would need a telescope. However, there are astronomers out there who can look at this with their naked eye. Of course, these are people who existed a long time ago. In fact, they're named after these. One's named after an astronomer named Nicholas, and one's named after an astronomer named Mendeleev. Okay? So, could you count all those craters? Just by looking at that?
No.
Okay. What's great about this is we don't have to count all of them. We have a wonderful tool called the Lunar Reconnaissance Orbiter, or the LRO, that goes around the moon and takes pictures. And so what we have determined is, with those satellite pictures provided to us by the LRO of the Maria and the Highlands, that the craters on those are just, some of them are just as the same height as another crater known as the Tycho crater, which has a little peak in the top of it. So, we also want to be able to figure out not just how many craters there are, we also want to figure out how old they are, because both of these were formed from volcanic eruptions. Okay? And so both of these have different material in them, and we want to be able to figure that out. So later in our space exploration, we can understand which surface is the safest for us to be on, and what resources we can possibly gather. So, we call that the cratering method, which is figuring out how many craters are on each surface, finding the difference, and then calculating it based on how old they are. And these were formed 50 to 60 million years ago. Okay? So, but of course we can't just calculate that by going there and just spending hours there, because we can't do that at the moment. So what we are going to do is we're going to study it in a way where it is feasible here on Earth. So we're going to look at trees, specifically how old are trees and how you can figure out the age. Now, is there anything you know about a tree's age?
The trunk has a lot to do with it.
Okay. Is there anything visual or tactual about the trunk that tells you how old it is?
Sometimes it can look dead, and then you notice that it's older because, like, some of its pieces are falling off.
Mm-hmm. So, what's really cool about a tree is they have rings on the trunk. So those rings grow every year, and they tell you how old the tree is. So what we are going to do is we are going to make our own trees. We're going to make 2 tree trunks, and we are going to figure out which one is the youngest. So what I'm going to do is I'm going to take a piece of Play-Doh. Play-Doh, and I'm going to compress it into the lid to make a circular pattern. So that way it looks like a trunk. Whenever I have that taken out, I will put it on the table, and I will flatten it out a little bit to make it into a patty formation or a pancake. And then I will make a second one. Same process, same shape, because we want the trees to look similar. They don't have to look exactly alike, but we want to be able to count the rings and notice some differences. So I'm going to do the same thing. And then, the other thing I'm going to do is, now that we have our 2 patties, I'm going to place them on the table, going to take the edge of the lid, and I'm going to make some lines. These lines will represent the rings of the tree. Okay. So now that I have these indented with rings, they're really lines, I'm going to hand them to you, Jessica.
Okay.
And what I want you to do is count how many lines you feel on each of those.
Okay. So I can't look?
You can look.
Oh, okay. I counted like 6 or 7 on this one, and then like 5 on this.
Which one is the one that has the most? What hand is it?
The right one.
The right one? So your right hand, the patty near it has how many?
6.
6? Okay. So those lines represent the rings, and how many is on your left one?
4.
4. Okay. So now what we're gonna do is we're going to figure out how old these trees are. So every year a new ring grows on a living tree. So a year is equivalent to 365 days a year. It would be really easy if I just asked you what is the youngest tree? What is the oldest tree? But we are going to figure this out in terms of days. Okay? So what I would like you to do is I would like you to pull out your phone, if it has a calculator on it, and what I want you to do is I want you to take these 2 and multiply it by 365.
Each one?
Each one individually.
Alright, we have 4 360.
Mm-hmm.
That's 1,460.
Okay.
And then we have. Oh wait, I missed. Oh yeah. Sorry about that. And then we have 2,190.
2,190. Can you repeat those numbers?
So we have 1,460 and then 2,190.
Okay. And which one has the 1,000?
The one with the less amount of rings.
The one with the 4 rings on it?
Yes.
Okay. And then the one with the 6 rings has the 2,000 and what?
2,190.
Okay. So, which one do you think is the youngest?
The one on the left, the one with 4.
Okay. And the oldest is obviously this one, correct? The one on the right?
Yes.
So now that you understand that, of course, with the cratering method, we do it differently since it is an estimate. It is not an approximate answer like 1 year with a tree. So we would typically take these two trees, if we had to estimate how long they take to grow a ring, we would have to take the difference of it. So since we have 6 and 4, we would do 6 minus 2, which would be 2, and multiply that both by the cratering method, which is times 50 million years and 60 million years. And that would get us our answer. But this is a tree, and it takes exactly 1 year to grow it. So, can you do one more thing for me, Jessica? Can you take these two Play-Doh sculptures and place them on the correct crater, based on what you know now?
This is the younger one, and then this is the older one because I placed the one
Okay.
more.
Perfect. And so that is how we determine how old a crater is. That is how we determine the composition of these two surfaces, and that's how we also determine whether or not it would be a good place to land or look for resources. So thank you so much. Appreciate your help. We have also a guy who's helping us do camera, Josh, so thank you. And that is all for this month's assignment.